world is immense, beautiful, and largely unexplained. Its many intricate formations are of great importance to our pursuit of knowledge. Dark matter is a network of invisible mass permeating the entire universe, and it's the reason all these marvelous structures are held in place. Dark matter is a concept that might help close a major gap in our understanding of the universe. So, what makes it dark? Well, it's impossible to see. We haven't quite yet been able to detect it. This is because dark matter doesn't emit any light, or in fact interact with regular matter at all. Dark matter doesn't exhibit any of the fundamental forces like the electromagnetic or strong nuclear force, only gravity. Therefore, we may only infer the existence of dark matter when we look to our surroundings. Vera Rubin, an American astronomer, in 1970 obtained the strongest evidence for dark matter up to that time by observing the angular velocities of the stars of the Andromeda galaxy. She found that the stars on the edge of this galaxy move much too quickly. The farther apart from the center of the galaxy, the greatest concentration of mass, the slower they are expected to move. Except, the stars in the galaxy moved with about the same velocity no matter their distance from the center. So the stars at the edge of a galaxy should have either been flying away or else being held in place by some gargantuan amount of invisible matter. There are many inexplicable phenomena in the universe that would very conveniently be accounted for by dark matter, such as gravitational lensing. When we look to greatly distant galaxies, we notice distortions in their image. In this case, the light coming from a galaxy is bent by gravity by a mass positioned in between the galaxy and telescope. Sometimes, the object we observe is at the perfect distance, such that the distorted light converges on the telescope at different angles, creating a duplicate image. Thing is, we can't directly observe any normal matter massive enough to cause such an effect, and so dark matter must be the key. Dark matter must be made of some extremely massive but otherwise completely neutral particle. Candidates include WIMPs, weakly interacting massive particles, including axions or super heavy, sterile neutrinos, all of which are hypothetical particles that carry no charge of any kind. They result from extremely high energy particle collisions, but being so weakly interacting, as the nomenclature would suggest, they are very difficult to detect. There are many cutting-edge experiments underway and in the works as of right now, worldwide. A leader in research is the LUX, Large Underground Xenon Experiment in a facility 1,500 meters underground, isolated from cosmic radiation. Particle interactions in a large chamber filled with 370 kilograms of liquid xenon will produce specific wavelength photons or electrons. For now, this particular journey of our curiosity remains primarily theoretical. More than a century ago, who could have imagined the implications of the electron's discovery on modern technology? What secrets does dark matter hold in store for us? In the meanwhile, it is certain that we may continue to appreciate the beauty of the cosmos in our ever-expanding quest for knowledge.